Alright, so this video kind of fits in between 1.1 and 1.2, but it is for one of the homework problems, quiz problems, and that is, how do we solve for quadratic inequalities? So something like solve for where x squared minus x is greater than or equal to 0. Okay, so a lot of us would just go ahead and say, well, if x squared minus x is greater than 0, then we would take x squared is bigger than or equal to x, right, by adding x to both sides. Now this is where the problem comes in, because if you try to divide both sides by x, we don't know if x is positive or negative, and so that's going to mess up this inequality, and so we can't do that. So instead of doing that, let's think about it a different way. In a quadratic inequality, we can factor the quadratic, and so factoring the common x out of that expression, we end up with that inequality. Okay, and this one is going to be a lot easier to solve, because now the way to interpret this is this statement is true if a couple of things happen. If x is greater than or equal to 0 and x minus 1 is greater than or equal to 0, or B, if they're both negative, x is less than or equal to 0 and x minus 1 is less than or equal to 0. It'll be false if x and x minus 1 have different sign. Okay, and so what we need to know then is for what values of x is x greater than 0, and for what values of x is x minus 1 greater than or equal to 0. Okay, so by the way, I've got some construction going on in the background, so ignore the weird noises back there. So I'm going to take this expression, I'm going to move it down here and say, okay, I want to figure out where x times x minus 1 is greater than or equal to 0. Okay, and so from what we just said, it depends on where each factor is greater than or equal to 0. So I'm going to list each factor off to the left here, and underneath I'm going to put a number line, and so I'm going to go through each of these and see where the thing is positive or negative. So x changes sign at x equals 0, and x minus 1 changes sign at x equals 1. Okay, and so these numbers down here then are where each of the factors changes sign. Okay, so that splits the number line into 3 pieces, right? Okay, so now we need to go through each piece and see if our factors are positive or negative. So x is negative here. Then if x is greater than 0, if x is positive, then the expression is positive, I should say. And then similarly for x minus 1, if we have a number that's less than 0, like a negative 1, then negative 1 minus 1 is negative 2, so that's also negative down here. So between 0 and 1, it doesn't change sign, it's still negative. And then if x is bigger than 1, it's positive. Okay, so this thing right here is called a sign chart, and it helps us figure out quadratic inequalities, because now we see, in this region, x is a negative factor and x minus 1 is a negative factor. Negative times negative is positive, and so that region works for our inequality. In the region between 0 and 1, we have a positive number times a negative number, so that's going to be negative, and so that's not going to work for us, right, because we want our numbers positive, so that does not work. And then if x is bigger than 1, both are positive, and so that means that's part of our solution as well. And so we can say that x times x minus 1 is greater than or equal to 0 if x is less than or equal to 0, or x is bigger than or equal to 1. Okay, and so that's how we would solve a quadratic inequality. Good. Now, if we're putting together the entire x, you could say this is and, so this is, you could put that as an and, right, if you wanted to figure out where all the x's are. Okay, and so if you wanted to write this, the reason I'm writing it that way is because, you know, if you wanted to write this in interval notation, you would write it as minus infinity to 0 with a square bracket, and then 1 to infinity. Good. And so that's how you solve a quadratic inequality. By the way, it doesn't have to be quadratic. How would you solve x times x plus 2 divided by x minus 3, oh, let's say x minus 1, is negative? Go ahead and pause the video and see if you can solve that using a sign chart. Are you back? Let's try it. So we're going to put our factors off to the left, and then we're going to build a sign chart along the number line. And down here on the number line, we put our factors, or where each factor is equal to 0. So x equals 0 takes care of the first one, or the top one. X equals minus 2 gives us the next one, so that's our, and then x equals positive 1 is the next one. So this breaks our number line into 1, 2, 3, 4 pieces. Whoops. Okay, so if x is less than negative 2, that's negative, and then negative, and then positive. Okay, x plus 2 changes sign at negative 2, so that's negative, positive, positive, positive. And then x minus 1 is negative, 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 positive. And you can go slowly through each region. What you can do is you can take a test point in each region if you wanted to go a little bit slower there. So for example, in this region you would take x equals 1/2, and in this region you might take x equals 2 and plug those in to see what the signs are, and so on. Here you might pick a negative 1, here you might pick a negative 3. Okay, good. And so now if we take the product of the top 2 divided by the bottom, where is that going to be negative? Well, it's going to be negative here because the numerator is positive and then the denominator is negative. So this is going to be negative overall. In this region we have negative divided by negative, so that's positive. Here we have positive divided by negative. That one works as well. And then over here we have all positives. In case we have two intervals that are possible, we have x is less than negative 2, or x is between 0 and 1. And in this case I'm not including the points 0 or 1 or negative 2, right? Because we want our inequality to be strictly less than. Good. So there's two examples of solving inequalities where you have factors or quotients. Good.